All right, now this is coming from a student in the free class, all right? And it's actually a physics question. So this is Dr. Tam K, and this is Duoco Maths Lab, all right? So we're going to be solving a physics-related question as it is, and this is a WAEC past question as it is, right? I think this student is praying for WAEC, so he sent us this and he asked us to help him to solve this, right? All right, now when you hear the word microfarad this way, all right, and that is actually 10 raised to the power of minus 6, all right, 10 raised to the power minus 6, okay. Your 1 microfarad is equal to 10 raised to the power minus 6, all right. But then we have to calculate that in series first of all. Now capacitance in series is actually inverse, okay. 1 over ct equals to 1 over c1 plus 1 over c2 plus dash 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 into infinity. Exactly, that is for the series. Exactly. Now for parallel, if capacitors are in parallel, what we do is what ct equals to c1 plus c2 plus c3 and so on. Okay, that's for parallel. So we're going to be using this one which is in series. 1 over ct equals to 1 over c1 plus 1 over c2 and all of that, right? So I'm going to have 1 over 5 plus 1 over 15 plus 1 over 25. Okay, those are the values that were given to us, right? I hope you take note of that, right? We have 5, 15, 25 all in microfarad. Okay, so what we're going to do is take the LCM of what? 5, 15, 25. The LCM will be 75. Now 5 into 75, okay, that's going to give us I think that will be 25. No, that will be 15, right? That's going to be 15. Is it clear? Okay, because 5 into 5, 5 into 7 is actually 1. You have 2 left, and the 5 into 25 is 5. Okay, now 15 into 75, 75, that's going to give us like, if the common denominator is 75, okay, 15 into 75 is going to give us, 5 into 75 is going to give us 15, and then 15 into 75 is going to give us 5, and 25 into 75 give us 3. So add up this, all right, that's going to give us 23, right? So we have 23 divided by 23 going to be divided by 75. Okay, 23 by 75. Remember, this is 1 over ct, right? Let me show you. 1 over c is equals to 23 divided by what? 75. Okay, that's what we have here. So what is your c? Your c over 1, if you reverse it, it's going to give us 75 divided by what? 23. So you're going to get a calculator, divide 75 by what? 23, and so you're going to have your answer in decimal format, right? Okay, so if you grab a calculator, we have 75 by 23 give us 3.26086 approximately. All right, it's going to give us 3.26. okay, approximately that will be our value. So that's going to give us ct, that is the net capacitance. We're going to be about 3 point what we got just now, 3.26. all right, got 3.26. okay, remember this is in farad, all right, microfarad. Now let's take it to farad. If we to take that to farad, that's going to be 3.26 times 10 raised to the power what? Minus 6. all right, 10 raised to the power minus 6. That will be a value for the first part of the question, right? So let's take a look at the second part of the question. Now the second part of the question says we should find the voltage across each capacitor. Now because they are in series, okay, when the capacitors are connected in series, the voltage that passes across each capacitor, or the voltage that pass across all the capacitor, or each capacitor, is going to be what? The same voltage. So in series, for Roman figure 2, this is actually Roman figure 1, right? This is Roman figure 1 answer. All right, guys, we're able to solve the first part of the question, all right, which is this. All right, where we got 3.26 times 10 to the power minus 6 farad, right? So what we're going to solve is now the second part, which they ask us to solve the voltage across each capacitor. Exactly. So let's take a look at that. All right, follow me as we do that. All right, so if you look at it, the total capacitance we got is 3.26 microfarad. Remember, microfarad is 10 to the power minus 6, right? Farad, all right? If you have to convert that to farad, that is 3.26 times 10 to the power minus 6, all right? Good. Now, what is the voltage across the first capacitor? That is C1. But as for us to solve, we're going to get what's called the voltage divider rule, all right? So V1 is equal to V times C1 over CT. Exactly. So that's going to give us the voltage across C1. And then we'll go to voltage across C2, voltage across C3. Exactly. So on that note, our V1, the V1 all right, will be equals to, hold on. So that's going to be like the voltage that was given to us 15, right? Time the capacitance across that first one is 5 over the total which is 3.26. All right, time 10 to the power minus 6. Okay, let me clear that. I wanted to make sure you see that. Okay, what I can do is just say 3.26 times 10 to the power minus 6. All right, make sure you get your pen and your paper. All right, 10 to the power minus 6. Okay, take note of that. So what we're going to do is we multiply 15 by 5, divide by 3.6, and then we are good to go. Okay, so let me do that. Your 5 times 5 is 5. Then 5 times 1, 5 times 5 is 25, right? Write down 5, carry 2. 5 times 1 is 5, plus the 2 you carry, that give us 75, right? Okay, 75 all over 3.26 times 10 to the power minus 6. Make sure you get your pen and paper, right? Because you may not be able to understand some of my handwriting, right? Because of the small board we got, right? Okay, that is, I'm trying to write minus 6 here, right? Very good. So what we're going to do now, take that to standard form. That gives us 7.5 times 10 to the power 1 over 3.26 times 10 to the power minus 6. All right, so we're going to divide 7.5 by what? 3.26 with our calculator. 7.5 divided by 3.26. Is that what it got? That's going to give us 2.3 approximately, right? So we're going to get 2.3 times, then for the powers, we have 1 here, we have minus 6. So that's going to become 1 minus minus 6. This minus 6 will cross up, right? Become 1 minus minus 6. And then 1 minus minus 6 is 1 plus 6. And that's going to give us 7. Okay, we're going to get what? 2.3 times 10 to the power 7 volts. So this is the voltage across C1. This is voltage across C1. Now for voltage across C2, okay, you're going to get V2 equals to the voltage given to you times the C1 and the C2, now the capacitance 2 all over CT, the total capacitance. Okay, with that you can also get us V2. For V3, the same thing. Your V3 equals what? Your the total V given to you times what? C3, capacitance C3, then your CT. All right, that's going to give us that CT means total, right? So that we can get to V2, V3, and all of that. Okay, for you to get this done. Is that clear? To give us that. Let's look at Roman figure 3. Roman figure 3 says, let's take a look at the question again. Roman figure 3 says we should find the energy stored in the 15 microfarad capacitor. All right, so for us to do that, we're going to use a formula. Okay, we're going to use this formula that says W, which represents the energy stored, equals to 1 over 2 CV squared. All right, CV squared. Let me write that clearly for you. CV squared. Is that clear? That is the formula to calculate the energy stored in the capacitor. So on that note, we're going to get 1 over 2 times the C, which is the capacitor. The capacitor is 15, all right? 15 microfarad. Is that clear? Multiplied by the voltage. The voltage is also what? 15 raised to the power of 2. Is that clear? So what we're going to get is this. We're going to get 1 over 2 times 15 times 10 raised to the power minus 6. All right, 10 raised to the power minus 6, which represents the 15 microfarad. Microfarad is 10 raised to the power minus 6 times 255. Is that clear? 255, because 15 squared is 255. So that would give us 1 over 2 times 15 again times 10 raised to the power minus 6. All right, 10 raised to the power minus 6 here. Please make sure you have your pen and paper right now, okay, so that you will not mess it up, right? Because my board is very small, I have to manage it. That will give us 2.6 approximately. Let me use approximate value, right? Your 255. I'm taking this one to standard formula. Okay, we'll go to standard formula. If you take that to standard formula, you're going to get 2.6 times 10 raised to the power 2. Okay, approximately. All right, that's what we're going to get. So what do I have here? Now 2 can divide 15. If you 2 divide 15, you're going to get 7.5. So we're going to get 7.5 times 10 raised to the power minus 6, and then times 2.5 times, 2.6 that we got, right? That is 2.6. All right, 2.6 times 10 raised to the power 2. All right, so if you have to do that in standard form, you take the 7.5, this 7.5 multiply 2.6. Okay, let's carry calculator. So we're going to have 7.5 multiplied by 2.6. All right, that gives us 19.5. Okay, so we're going to get 19.5. All right, that will be equals to 19.5 times here 10 to the power minus 6, 10 to the power 2. So minus 6 in standard form, you have minus 6 plus 2, obviously, right? Minus 6 plus 2 will give us what? Minus 4. So here we're going to have 10 to the power minus 4. Okay, now if you have to take this to standard form, this one will cross over here, become 1.9. so we're going to get 1.95 time, because the point has moved only once, you have to remove 1 from this minus 4. That would give us 10 to the power minus 3. All right, minus 3. All right, in terms of what we are calculating, what, hold on. All right, so if you have to take this one to maybe 1 decimal place. Okay, now because you are going by standard, right? Standard value 7.5 at 2.6 are actually 1 decimal place, right? So we can actually take this one to 1 decimal place. If you have to take this to 1 decimal place, your 5 to 9 going to give us 10. All right, obviously that's going to be like 2. All right, obviously here our value going to be like 2. Going to be like 2 times 10 to the power minus what was the value there? 10 to the power minus 3. All right, yeah, 10 to the power minus 3 in joules, because we are calculating what? Energy. So this would likely be the answer. So if you can actually leave your answer in this form for the number you got 3, or you can actually leave it as what? 1.95, which you got times 10 to the power what? Minus 3 in joules. All right, either of this is okay.